For lesson 9.4, we're going to be looking at if we're given enough information in order to decide that the two triangles are congruent. So remember, we have 5 shortcuts that we can use, and those are SSS, SAS, ASA, we need a different pen here, ASA, AAS, which is the same thing as SAA, if I can talk. And then remember, our new one is for right triangles only, and that is HL. So these are the only 5 ways that we can prove triangles are congruent without having to prove all 6 pair of corresponding parts are congruent. So in number 1, it says, are we given enough information to prove that these two triangles are congruent? And if so, what one of those 5 reasons would we give? So in this drawing, we have 2 angle pairs that are congruent to each other and a side pair that is also congruent. Now, we have 2 ways of using 2 angles in one side. It can be ASA or AAS, but it depends where the side is. So if the side is between the 2 angles, we use ASA. If it's not, we use AAS or SAA, however you want to word that. Well, this one is not the included side. The included side would be AB and EF between the 2 angles. So in this case, we're using AAS. Yes, we'll answer that question. Are you given enough information? Yes. And if so, what reason would we give? AAS, which remember is the same thing as SAA. So if you wrote SAA, that would be fine. Now if you write ASA, that will be wrong because that's not the shortcut we're using here because the side is not the included side. Number 2 wants us to write the congruent statement. So they're giving us the naming of the first triangle as triangle ABC. So remember, we want to show the corresponding parts by the way that we name the second triangle. Now don't forget to start off the naming of your triangle with a triangle symbol. So sometimes that is left out. Students just go straight to writing letters, and so you miss a little bit of points there by doing that. So when we look at the order of ABC, angle A is the angle with 2 arcs in it. So I'm going to look over here for the angle with 2 arcs in it, and that's going to be the first letter of this triangle name. So it would be F. B in the first triangle has 1 arc. 1 arc goes with E in the second triangle. So obviously there's only one other vertex to use in the naming of the second triangle. So it would be triangle FED. So starting with number 3, they're going to give us some information, but as you notice, nothing is marked on the figure itself. So you're going to have to use the given information to draw on the figure the tick marks and arcs that you would know as a result. So for example, it says on number 3 that we're supposing that D is the midpoint of 2 different segments. It's the midpoint of segment GE and it's the midpoint of segment FH. Now we should know what a midpoint is at this point. We know it is the point that bisects a segment into 2 congruent parts. So if D is cutting GE into 2 congruent parts, I can mark with tick marks the length from E to D being congruent to the length from D to G, because D is the halfway point of that segment. Now it says it's also the midpoint of the other segment, FH. So it doesn't mean that this segment is congruent to this one. It just tells me D is the halfway point of this segment as well. So this time when I use tick marks, I'm going to use 2 and say that these parts are congruent to each other. Now at this point, that's all it told me, and I know that 2 pieces of information is not enough to prove that triangles are congruent. Yet there are some things that we have learned that we would know to be true all the time. We wouldn't have to be told it's true. So for example, is there anything else you know to be true in this drawing that you can mark without having to be told it? Hopefully you recognize that you have some vertical angles here. They're the non-adjacent angles when 2 lines intersect. And remember, vertical angles are always congruent by the vertical angle theorem. So I can mark this angle being congruent to this one without being told that. I should be able to recognize that by now. So now we do have 3 pieces of information. Is it enough to say the triangles are congruent? Well, I have 2 pairs of sides and an angle. Well, we can only use 2 pairs of sides and an angle if the angle is the included angle, right? If it's not, it's that bad word that we can't use as a shortcut, right? So in this case, yes, the angle is between the two sides. The angle is between the two sides. So are you given enough information? Yes. If so, explain my reasoning. Well, my reasoning is the shortcut SAS, two sides and the included angle. So now we should be able to complete the congruent statement. Again, they've named the first one for us, triangle FDE. Remember, when we start naming the second one, we're going to start off with the triangle symbol and look for those corresponding parts. So when I look at vertex F, I notice it's between the side that has 2 tick marks on it and a side that has none. So I'm going to look over here for the vertex that is between the side that has 2 tick marks and the one that has none, and that is H. So that is the first letter used in the naming here. D is the vertical angle that we have an arc in. So when we look over here, the vertical angle we have an arc in is also called D in the second triangle. Now remember, it doesn't mean every time you have the same letter that that's going to be in the same place in both wordings, okay? So be careful about that. But in this case, they are. And then also our third vertex would be G. And we can see that it corresponds to E. Between 1 tick mark and none, between 1 tick mark and none would be G over here. So triangle HDG. Number 5 uses the same figure, but we're not given the same information. So we have to pay attention to what information we are told. So in number 5, it says we don't know anything about point D. So it is no longer the midpoint. We're not going to be marking that. Instead, we are told that segment GH and FE are parallel. Remember, that's what that symbol means. So on your drawing, to show that these lines are parallel, you use an arrow. That's how we show parallel lines. It says, can we prove the triangles above, are congruent? Well, when we have parallel lines, remember we have learned some special angle pairs that we should be able to mark at this point. So, for example, we've learned if we can make a Z with our parallel lines, then we know that we have alternate interior angles. So here I'm drawing a Z with my green pen, and that shows me that this angle and this angle are congruent because they are alternate interior angles. Now I can draw a Z the other direction using the same parallel lines, but now using this side as the transversal. So my red pen's not working that great. Using some Christmas colors there, aren't I? So I have a Z here, so that would show that this angle, I'm going to put 2 arcs this time because I'm not saying these are congruent to each other, and over here are alternate interior angles as well. Now don't mistakenly think these arrows mean these sides are congruent. Remember, these arrows mean that those sides are parallel, not congruent. So right now I only have 2 pieces of information that are given. And remember, 2 pieces of information is never enough. But don't forget, the same thing that we knew without being told is true up here is true down here. And that's that these vertical angles have to be congruent to each other as well. We don't have to be told that information. So that's really all I can mark. There aren't any side links that I can say are congruent, just knowing that I have parallel lines. So we do have 3 pieces of information, but this would be AAA. And just like SSA is not a way to prove triangles are congruent, AAA is not either. And so can we prove the triangles are congruent? No. And our reasoning would be AAA does not prove triangle congruence. It's not one of our shortcuts. All right, so let's look at number 6 in our notes. If you'll notice, we have the same exact drawing. Again, we're given different information. This time we still know that we have the parallel lines, EF and GH. But this time we are told that they are also congruent to each other. So this time I can put a tick mark on each one. So it says, can we prove the triangles are congruent again? So remember, if these lines are parallel, I have the same alternate interior angles that we just looked at. So angle FED and angle DHG would make a Z together. They are my vertical angles. And likewise, angle FED and angle DGH are still vertical angles. Now, the alternate interior angles, I hope y'all knew that's what I meant. I did not say that. So these are alternate interior, these are alternate interior. They make a Z. All right, and then we know our vertical angles are also congruent. So we actually have 4 things that we can mark as being congruent in this figure. 3 angles and 2 sides, or a pair of sides, I should say. So 3 pairs of angles and 1 pair of sides. Well, we don't need 4 things. We only need 3 things. And so that means there's really more than one way that you could prove the triangles are congruent. But we definitely, when it says, can you prove the 2 triangles are congruent, our answer is definitely yes. But our reasoning, we have a couple of different options here. If I use my alternate interior angles with the side that I was given to be congruent, that side is between those angles. So remember, that would be ASA. That's one way. And you don't have to put more than one way, but I'm just going to show you that you had options. The other way is to use 2 of the angles and the side with it not being the included side. So for example, if I use these 2 angle pairs and that side, then that side's not between those angles. So that would be SAA, which remember is the same thing as AAS. So either one of these would be a shortcut that would be your reasoning for the triangles being congruent. Either one of those would work. Okay, so what we cannot use is AAA, right? That's not a shortcut. On number 7, in this diagram, we're told D is the midpoint of segment AC. So remember, that allows me to automatically say that the parts it divides it into are congruent to each other. And I'm going to use 2 tick marks since they already have 1 tick mark for the other piece of given information. Segment AB is congruent to segment CB. It says, can we prove any triangles congruent? Well, if you remember, we learned this already back in topic 7. I think it was lesson 7.5. Since these sides are congruent, this is an isosceles triangle. And so when we have this segment coming down to the midpoint, that's the median, well, that median's also a perpendicular bisector. So we have a right angle created here. And remember, we learned that that perpendicular bisector separates the isosceles triangle into 2 triangles that are congruent. It's just that now we know what reasonings we can use. And we actually have a lot of different reasonings that we could use here, because this side, that's the shared side between the 2 angles, is congruent to itself. So remember me saying we're going to be using the reflexive property, I promise you. Here it comes up. BD is congruent to itself by the reflexive property. So I could use all 3 sides as my shortcut. So again, my answer is yes, and one of the shortcuts I could use is SSS, but that's not the only way. Since it's a right triangle, I could use the hypotenuse in either one of these legs, and so I could use HL as a shortcut. Also, since it's an isosceles triangle, I know these base angles are congruent, so I know this angle is congruent to this angle, so I could use SAS as a shortcut. And since this angle is a right angle, we also know this one's a right angle. I could use ASA as a shortcut. Now, we've almost used all of them. We used them all except for SAA. And guess what? We could use that one as well, because we have this side and that angle and that angle. So really, any of our 5 shortcuts would work on that isosceles triangle. All right, finally, number 8, it says to look at the triangles, and suppose we know that CD and XY are congruent, DE and YZ are congruent, and C and ZX are congruent angles. So we have 2 sides in an angle, but remember, 2 sides in an angle only works if the angle is the included one. The included angle of these sides is angle D. The included angle of these sides is angle Y. We don't know that one. So instead, this is that bad word that does not prove triangles are congruent. So the answer to this one is no, because SSA does not prove triangle congruence. And that's all of our time.